The Hi, welcome to the shop. The metal parts are off at the plater and anodizer, and I'm making some more parts that don't require plating or anodizing. The parts that I'm making today are actually made out of steel, but they go in pretty much unplated, I'm not going to do anything, not going to paint them, not going to do anything, but I am going to lubricate them. They're internal mechanisms inside the clamping mechanism that will be lubricated with grease and protected inside the clamp housing. And because of all of this, I don't believe they need plating, and the tolerances are fairly tight, and I just didn't want to deal with plating because it is steel sliding against steel, and I didn't want plating flaking off, and they're full of grease and they seem to work perfectly fine as they are. This little part that I'm making today is going to be the clamp cam, and it's got a kind of a tricky little holding fixture where the blank, which was a piece of 1/2-inch cold rolled stock, was cut to length on the chop saw and then sanded off and deburred on the disc sander. So lining up the little chamfer at the 0 point, and actually let me, tool number 59. I'm going to run this program once with nothing in the vise just to make sure. It ran perfectly last time, but hey, you know, CNC is full of surprises. So okay, that looks sane. Got my finger on the stop button just in case something goes wrong. That looks sane. That looks sane. That's an unfortunate, I mean, that's the way the program works. It's a kind of an unfortunate side effect of the way the toolpath generator generates toolpath. So let me go ahead and just throw the old eyeball on it. This cam is going to be cut in this area of the blank using a slitting saw, and gotta make sure everything clears, getting the feed in and the feed out and making sure there was no interference was somewhat challenging back when the part was being designed, but at the moment I think it's working correctly. So finger on the stop button, single block mode, gonna give it a try. Worked perfectly last time, hasn't been modified. That's looking sane. Make sure I have coolant going here. It is cutting steel. And I'm taking this very slow, very conservative. I haven't tried optimizing this one for performance. I'm mostly just concerned that it works at all. 5 inches per minute, 500 RPM, a 2-inch diameter slitting saw, finger on the stop button, safely returning, safely clearing in rapid. I think it looks good. The part is held into the fixture with a 1032 set screw, and I don't want to tighten the screw down too tight because, well, it's only 1032 into aluminum and it might strip out. It also might booger up the surface, which I don't want to do, and so I don't have extremely good control over the part twisting in the fixture, which is another reason that I'm being very, very conservative in the amount of cut that's being taken. Clamp cams have been completed successfully. The next piece that I'm going to make is the clamp gripper, which is not really a super interesting piece. I'm just going to cut a slot, a groove, into this piece of 1/4 by 3/8 cold rolled. It's one of the more precise parts in the machine, and the width of the slot and the parallelism and the clean square corners need to be really accurate within a few thousandths. So I made this special set of soft jaws just for this purpose that grips a substantial portion of the metal. I didn't want to just barely grip the bottom of the piece with a really short ledge. So this set of soft jaws clamps most of the piece, and then the cutter, I've got cutter relief built in to the soft jaws, and then the cutter goes in and cuts away a bit of the soft jaws. Because machining steel, it kind of causes some cutter wear. And I don't have one of my super cool screw-in stops, so need to use the manual stop. Because cutting steel results in cutter wear, I'm doing this because I want to keep the tolerance really under control. I'm doing this with 2 cutters. The first cutter is my roughing cutter, and I know that my roughing cutter is going to get worn down over time. The finishing cutter only takes very small finish cuts, and so it tends to stay in better condition for a longer time. So let the roughing cutter take the abuse. Finishing cutter comes in, barely touches the surface, and holds a better tolerance. So I'll be using what I believe is a known trusted tool path, but hey, still gotta be careful. On the stop button, single block mode. Looking good. Thousand RPM. 5 inches per minute. 4-flute solid carbide cutter. As I said in previous videos, I'm a lot more experienced machining aluminum and have been little bit by little bit trying to optimize cycle time and speed things up by maybe pushing a little hard. In steel, every time I try pushing hard, I burn up cutters and break cutters and ruin parts. So I'm just keeping it really conservative. Someday, if I ever get some spare time for just learning, I'll probably further investigate high-performance steel milling to see, well, are there tricks I'm missing? Some combination of feed speed, coolant, part geometry that would allow me to be more aggressive. And then, of course, you know, it's a Tormach, and so aggressive is not exactly something that works well on this guy. So here comes the finish cutter. Single block finger on the neoprene pieces have been glued into place and roughly trimmed using an X-Acto knife and sandpaper. The critical part, which is this surface, is still protruding a little bit. It's still a little long. And now I'm going to put it back into the same fixture that was used to make it, and then mount the fixture here in the Bridgeport vise. The 0 point has already been set using the Heimer indicator, and I'm going to attempt to finish the surface with a milling cutter using a 5/16 diameter, nice new sharp one. And I'm hopeful, if everything goes right, that I can dial this in and get the tolerance correct and not have to hand fit every one of them. But if I get it close, if I get it within a few thousandths, and then just need to use the fine sandpaper to get that last little bit of adjustment, that'll be fine. So let's see if this works. And before I start the program, I need to set the Z height, set Z0 here, so I don't go too far into my tooling plate. So here we go. Going to be running at full machine speed, 5 inches per minute, and hopefully the rubber will cut cleanly and not just get caught in the cutter and break everything. Well, that is good news. It appears there's a little bit of a kind of a rubber burr on the surface here, on the top surface. And looks like a slightly rough cut. I'm going to go into the electronic shop and mount one of these into a case and up against the circuit board and see how close it came out. But I'm optimistic. All these, the little various different dangly bits can easily be trimmed off as long as the bulk of the surface is either in the right place or close to the right place. So looking good, actually. I think this might be a winner. It might require very, very little in the way of precision hand fitting. So I'm going to go try it out and then report the results. So it's very, very close. I looked at it under the microscope and it looks like the mill did a nice job. I think I'm going to leave the tool path as it is and continue just roughing them to this size with the mill and then doing the final hand fitting with the sandpaper. I don't want to try to get it within 1,000th milling rubber. I think that hand fitting is going to be better, but getting it this close with the mill really reduces the amount of hand fitting that I have to do. And so I think I'm going to call this a success. The machining process is now complete for all of the parts of the production run 4. And wow, anodizing is complete. I'm waiting on plating and powder coating. And wow, units will be available very soon now. Thank you for watching. It's been fun.